Okay, so thank you very much. And without wasting our time, I'm going to start my lecture. All right. So our topic is basically the exploration methods in order to explore your oil and gas reservoirs within a subsurface. All right. So we have multiple techniques in order to explore your basin, or if you are working in any specific block. So we have multiple methods in order to explore your blocks, basins, or to extract hydrocarbons from your reservoirs. So initially a quick view, because we have this course is basically 7 to 15 days course, so it is very difficult for me in order to wind up my lecture, my whole course in one lecture, so it is very difficult for me. But I'm going to try in order to wrap my all 7 to 15 days lectures. So basically if you are mostly you people are students, so I think you people have geology or petroleum engineering background. So initially we have a block system. All right, so in every country they have a specific rules in order to give the block to different exploration and production companies. So there is a specific department, like if I'm talking about in my country. Just like in my country, so there is a basically the department which is known as DGPC. All right, so DGPC offers a different bidding system in a year, and different exploration and production companies contact DGPC, and after bidding they acquire a specific block. All right, so every specific block lies in any specific basin. All right, so a team of geologists visit a specific basin, or you can say that your block location, in order to study the surface geology. So in surface geology, they only, you can say that study the dipping, striking component and dipping component and subsurface lithology, surface lithology of your block area, all right? So after that, when they collect all these data, or you can say that the information, so on the basis of these information we will carry out a survey which is known as seismic survey. All right, so initially we have basically two type of different multiple surveys are there, but initially we will carry it out only one survey, and this survey is known as, I'm going to use the paint software in order to show you that what are basically different type of seismic survey. All right, so the first method in order to explore your basin, or in order to explore your block, is seismic survey. But the thing is that if you know the surface geology, suppose if you don't have any surface geology, for example, if you are working on any desert condition area where no surface geology is exposed, only sand dunes are there. All right, and then if there is no information about the surface rocks, all right, so we will collect the information of the surrounding block, just like that. For example, this one is your block, all right, and this area is completely desert area. All right, so no geology is exposed. All right, then we will jump to surrounding, or you can say that the neighbor blocks. All right, just like that. For example, there is another block just like that, which is red in color. There is another block, for example, that is basically blue in color. So we will study the geology of the blue block and the surface geology of the red block. Let's suppose if we have no information, no surface information, which is basically again in a red block, no surface geology is there. In a blue box, no surface geology is there. Then we will carry out two type of surveys, and these type of surveys are known as magnetic survey or gravity survey. All right, so the gravity survey and the magnetic survey give us the anomalies. So if no surface geology is exposed, then we will jump to, you can say that, the gravity survey and magnetic survey. The magnetic survey and the gravity survey give us the anomalies, all right? And we will, when we consider these anomalies, then these type of anomalies give us the information about the basement rock and the bedrocks, all right? So if you have no surface geology exposed, if you have completely wildcat area, or you can say that the virgin area, then we will jump to the exploration methods, which is basically known as magnetic surveys, all right, or gravity surveys. Let's suppose we have such type of block which have basically, you can say that surface geology is there. When the surface geology is there, then we will carry out two type of surveys basically. So initially, we will consider the budget, all right? Because budget is very important thing in order to carry out your seismic survey, all right? So initially, we have such type of survey where we can study the subsurface dip information, also subsurface strike information, all right? And such type of survey, let's suppose I have four lines there, all right? Two are dip lines and the two are strike line. So such type of survey is basically known as 2D survey, all right? So this one is basically the 2D survey, which give you information about, you can say that the striking component of the subsurface, as well as the dipping component of the subsurface. Now, when we, the seismic interpreter, get this type of information, process the data set and interpret the data set, reservoir engineers make different type of models just like the dynamic model. And when the drilling team come and drill the on that location, then if they guys hit the valve just like that, and if there is something, all right, then they people, the company carried out the confidence of the, you can say that the company is now built up, all right? So they are not hesitating in order to put the money in order to carry out some another survey, and this survey is basically known as a three-dimensional survey, all right? So in three-dimensional survey we have a specific block, all right? So the block is just like that. Okay, so we have a block, all right? So which is basically black in color, all right? So in this block we will design a survey, all right? And this survey is known as three-dimensional survey. Why it is basically three-dimensional survey? Because it is basically, in that type of survey we have two different type of lines which are basically parallel to each other, all right, just like that. Okay, my drawing is not good, so kindly do not focus on my drawing, kindly focus on my concepts, all right? So these are basically the lines, all right? You can see there. So these lines are basically paired to each other, all right? And there are another type of lines which are basically perpendicular to these red lines. And the second condition of these lines are that these blue lines are paired to each other just like red lines. So you can see there, all right? Okay. So such type of survey is basically known as 3D survey. So in 3D survey, we have a full control on our data set, all right? So we can easily visualize our data set as a three-dimensional view. So these basically red color lines are known as dip lines, all right? While the blue color lines are basically the strike lines in three-dimensional survey. But if you are basically working in three-dimensional survey, all right, so then you are going to use different terminology. The dip lines in that case is known as basically the inlines, and the abbreviation of these inlines is basically IL. While the strike line in three-dimensional survey is basically known as cross lines, and this cross line abbreviation is just like XL. So the in lines and the cross line are parallel to each other, also perpendicular to each other. Now, in this type of data set, the seismic interpreter, the prospect geologist, geophysicist, or any engineer have the full data control. So due to full data control, they are going to visualize their data set in any direction, just like that. So I can interpret such type of lines or draw such type of line on my seismic survey. You can see there the yellow lines, and these type of lines which the prospect geologist and prospect geophysicist can easily draw on their data set are known as arbitrary lines, random lines, or if you are working in geoframe software, so it is basically known as OTF line, which means that I have full data control, all right? I have full control on my data set, so I can visualize my data set at any direction. Now, when we will carry out 2D survey, shows are there, hydrocarbon are there, so we spent more money, so we are going to make and you can say that the mark multiple wells, all right, and these multiple wells are just like that. We are basically now going to, our success ratio is increasing, and we can extract more and more hydrocarbons, all right. So we spent a lot of money. Why? Because in 2D survey, we have a shows in our well. All right. Now, we have another type of survey. And this is basically the survey which is basically carried out after some time. After some time of 2D or 3D survey, because in that universe, all right, so we have life of each and everything. If I'm talking about the living thing, or if I'm going to talk about the non-living thing, so each and everything have a specific life, all right, a specific lifetime. So just like a graph, all right, and the graph is just like that, you can see there. So it is basically going to start from zero, all right, then it is going to increase, life is going to increase just like that. Now after some time, all right, when it reach to a peak level, all right, then it stay a little bit there, all right. So this is the basically time where we have more and more, we can extract more and more hydrocarbons from our field. But just like a human life or living things life or non-living thing life, after some time our reservoir going to deplete, and this graph will become just like that. You can see there it is again moving down, all right, and it will become to zero, all right. So we have also lifespan of our subsurface reservoirs, all right. So the survey we will carry it out when we are basically on that point, then my team is or your team is completely happy. They're going to arrange some party in order to celebrate, because in at that moment they're extracting more and more hydrocarbons from their field. But just after that, there is a dark days will be there, all right. And when the dark days begin, then initially, as you know, we have carried out 2D survey, then we have carried out 3D survey. Then after some time, when our reservoir going to deplete, we are again going to carry out 2D survey just like that, or we will again carry out 3D survey just like that. And such type of survey, which is basically carried out after some time, is known as 4D survey. So basically 4D survey is fourth dimensional survey. In physics, you have learned that time is a four-dimensional quantity, and this survey is carried out after some time. Therefore, these type of surveys are known as 4D survey. So basically, you can say that the solid, basically the exploration methods are magnetic survey, gravity survey, and the more authentic survey, we have seismic survey. When we have before 70s, the seismic exploration methods were not there. All right, so the many companies and the many people are carried out gravity or magnetic survey in order to explore the hydrocarbons from the subsurface. But seismic is a latest technology, and within a seismic, now seismic is basically nowadays, the seismic methods are more and more reliable. Even you can calculate the TOC from your seismic data. You can predict hydrocarbon saturation from your seismic data. You can predict water zones, gas zones, hydrocarbon zones from your seismic data. All right. So you can easily detect different, you can say that the stratigraphic features, different fractures, different faults where we cannot able to see from our seismic data. We can study all these things with the help of different techniques and the latest techniques of the seismic methods. All right, so these are basically known as basically the expression methods. All right, and within a seismic, that I have told to you that we have 2D data set, 3D seismic data, and 4D seismic surveys. All right. So if you are talking about the exploration of your block with the help of gravity methods or magnetic methods, we can also use 2D survey, 3D survey, or 4D survey. So 2D, 3D, or 4D surveys are also present in gravity and magnetic. Also, these type of surveys are present in seismic exploration methods. So in order to study the different techniques, and we must jump, and we must know that what is basically, you can say that the seismic wave theories. All right, it is basically a normal theory that you have learned in the ninth standard or 10th standard, that what are basically seismic waves. So seismic waves are basically travel through the earth's surface. That's why we can extract different type of information, collect this information, process this information, and at the end interpret our data set. All right, so we have different type of seismic waves. All right, so the first one is body wave, and the second one is basically known as surface waves. So the body waves are the P waves and S waves, while the surface waves are the relay waves and love waves. So these four types of waves are there, and with the help of these four waves, we can some of waves are not interested, because in seismic method only P waves we consider the P waves. All right, if we are going to make our you can say, we can use S waves in latest you can say that the methods of seismic, but the relay waves and the love waves are basically completely the noises. All right, we don't need these type of waves. We only consider the body waves in order to make our seismic section. All right, so these two main waves are there. So what is basically the P waves? P waves are basically the first arrival. All right, so just like earthquake, when you feel the first jerk of earthquake, so this first jerk is known as P waves. So these P waves are basically low in amplitude. All right, and can travel through any type of material. All right, whatever it is, liquid or solid, it can be passed in different type of material. Now the second waves, it is basically also known as the compression wave, where the particle of the body is basically compressed, also expand. All right, so these are basically I'm going to show you at the end of this slide. I'm going to show you the videos. All right, so you can see there the compression zone, also the extension zone. So in P waves we have two type of zones there. All right, so the second one is basically the S waves, which is also known as the shear waves. All right, so now with the help of shear wave, the shear waves cannot passes through liquid or gases. So with the help of S waves, we can you can say that authentically says that the outer core, the mantle. If you study the mantle, upper mantle and lower mantle, all right. So we can easily say that this is basically the semi-liquid, because seismic waves cannot pass through liquid as well as the gases, all right. So these two waves are very important in order to make. So if when you feel the second jerk during earthquake, so this is basically the high in amplitude, and you can say that these are basically the S waves. You can see the red line. The first one is basically the first arrival, which is known as the P wave, while the second one is basically the S waves, which is basically the second arrival. And you can see the shape of your seismic wave, all right. Now we have relay waves, which is again high in amplitude, all right, very dangerous waves during earthquake, all right. And it is completely noise, because these are basically the surface waves, and such type of waves in seismic is known as ground law. So this type of the noise is known as ground law. The noise which is basically the cause of noise, which is due to the relay waves, is basically known as the ground roll, all right. So these are very destructive waves, just like you can say that the rolling, the waves body is basically the rolling. So therefore during earthquake, these waves are responsible to you can say that break or you can say destroy anything, destroy buildings, homes, roads. So these basically waves are responsible for all these things, all right. At the end, we have for love wave, again very very high amplitude as compared to all other waves. Again, these are basically the ground rolls, the noise, all right. We cannot consider such type of data in our seismic, all right, because this one is completely you can say that the noise. So just like a snake movement, so love waves are just like that, all right. You can see the wave direction, all right. So these are basically the exploration methods when we use different type of technologies, different type of explosive materials, or different type of source of seismic waves, just like vibrator or any dynamite. So when the vibrator vibrate the ground, or when the dynamite explode, then the waves are travel. You can see there the high amplitude and the low amplitude. So it collide the rock within a subsurface, you can see there. When it collide, all right, then with the help of this collision, the transmission, reflection, refraction, all of these phenomena will occur, and we can easily image our subsurface body. So these are basically the method that how we are going to explore our you can say that this seismic, all right. So now you can see there on the surface, we have P waves, which can easily you can say that penetrate within the outer core, inner core, and the mantle. While you can see that the S waves directions, S waves cannot pass through liquid, so therefore we can say that the mantle is semi-liquid, while the outer core is basically the you can say that the liquid material. So therefore, why? Because S waves cannot pass in liquids, as well as you can see that in gases. So such type of zone where the uh, you can say that the waves cannot pass is known as S wave shadow zone. So this is basically known as the shadow zones, all right. So these are basically the simple, I am quickly uh, uh, you can say that wrapping my lecture, because too much things are there in order to tell you. So this is basically the seismogram. We have first arrivals, primary waves, then we have S waves, then we have surface waves, all right, which is completely destructive waves, all right. So what are basically you can say that the vibrator, or you can say that explosive material, all right. So I'm going to show you in Google, all right. So So you can see there the different pictures. So these different pictures are basically the vibrators. So this is basically a more advanced, basically the tracks, all right, which contain, you can see that the hydraulic plate. The hydraulic plates are responsible in order to, you can see that, to shake the ground, all right. When these, you can see at the center, the hydraulic plates are there. These are basically touched to the ground surface and shake the ground. When these plates, hydraulic plates, shake the grounds, then seismic waves can penetrate within a subsurface, and after that we have the receivers, and these receivers are known as geophones, and geophones collect such type of, you can say that, the images, all right. So I'm going to show you geophones. So a vibrator are used where we have a smooth land, no mountains are there, no water are there, so we use geophones. So these are basically sorry, we, in that case we use the vibrator or vibro-size method, all right. So we have geophones. So you can see there the geophones, all right, where we can easily plug within a earth, upper earth surface, all right. So when the waves, when the vibrators shake the ground, then these are basically very sensitive to the waves, all right. So they acquire, collect the information, and at the end, uh, we can get the stacks, which is known as basically field seismic stacks, which is basically unprocessed seismic data, all right. So what are basically the unprocessed seismic data? You can see there too much noises are there. You cannot understand the, you can see that the field stacks. You can see there. This is the clear image, all right. So no information is there. Too much disturbance is there. But you can see here, you can recognize that where is a short location. So you can see there, and on that location there is a short, all right. The short is occurred, all right. When the short is occurred, then the seismic waves penetrated within a subsurface, all right, and the amplitude of seismic waves are decreasing. You can see there, you can see my mouse cursor with the passage of time. Therefore, you can see that these events are not straight. These are basically decreasing with the passage of time, because seismic amplitude are basically decreased within, you can say that, with respect to passage of time, all right. Just like when you throw a stone in a river or in a pond, then the, you can see that on that moment the waves, strong waves generated. These waves are expand, all right, on the surface of the earth, all right, on the surface of the water body, and then it collides and come back, all right. But when it comes back, then the amplitude of these waves are very, very slow, or you can say that very low. So therefore we cannot image, or you can say that therefore we have poor quality of data set, just like that. So these are basically known as field stacks, all right. Now when we process our seismic data set, all right, after processing, when we three steps are there: the data acquisition, when we collect the data uh, on the field, all right, then we process our data set, and at the end we are going to interpret our data set. So this is the basically the full process data set, and this one is basically the interpretation. I have a separate course which is basically related the seismic data interpretation in PetroNile software, all right. So it is very vast course, very broad course. So on that course I'm going to teach each and everything, that how we are going to use PetroNile software, and how we are going to interpret all these data set, all right. So if you're working in on offshore area, so on offshore survey, seismic survey, we have different technology there. We have a ship, all right. So just beyond the ship, we have another type of sources, explosive sources. So just like a huge balloon, all right, which contain a gas. When it explodes, then the waves propagate within a water body, also within a subsurface, and we have in on that case not a geophones but a hydrophones. So hydrophones are basically used if we have, you can say that, offshore or water body. So it is basically the waterproof system, all right. And you can see this one is basically the hydrophones, all right. So hydrophones on offshore area, we are going to use hydrophones, all right. So the seismic surveys are just like uh, you can say that differs three types, all right. In order to three different steps are there if you are talking about the seismic survey or gravity survey or magnetic survey, all right. In exploration methods, three steps are there. So the first step is in order to uh, collect your data set. So in order to collect your data set, the collection of your data set is just like your wheat field, all right. So in wheat field, you are going to collect each and every seed from your field. So this collecting of your seed is basically known as, you can say that, the seismic data acquisition or gravity data acquisition or magnetic data acquisition. Now if you are basically, if you belong to village, all right. So in village the women have a different type, a specific type of, you can say that, a net, all right, where they can process the wheat, and they can basically throw the wheat powder, all right, on, or you can say that the floor on that net, you can say that net shape, you can say that the ball, or uh, you can see that, I cannot recognize the specific word that how this net type of ball says. All right. So floor is basically on the net. So these women basically shake this net. So floor, the paver floor will remain at the bottom, and the some dust particles or any upper part of, you can say that, the wheat or any other raw material will left on that net, all right. So such type of, this step is basically known as seismic data processing, all right. Then at the end, when we get a perfect floor, then we are going to make different food, all right, in the form of bread, in the form of cake, in the form of pastries, in the form of each and specific thing. You can see that this step is basically known as seismic data interpretation, where you are going to make uh, specific things from your floor, right? From your processed floor. So these are basically three type of steps. If you are talking about, you can say that, uh, 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 expression in different expression methods, all right. So these are basically the field pictures. So you can see there, this one is basically the recorder where the all geophones are connected through these connectors. So these connectors are basically within that, uh, uh, geophysicists are there, and they are basically collecting the information and process the information. These are basically the geophones mounted within a subsurface. uh, you can see there the different wires. All these geophones are connected with the specific wires. You can see there wires are there, all right. Okay. So these are basically the vibrator, where we have a hydraulic system and the plate which shakes the ground, and the waves can penetrate within a subsurface. So these are basically the France-based vibrators, which is basically, I think, yes, it is basically Nomad 65, which is basically a France company. Vibrators are there, all right. So six vibrators or four vibrators are there. It is totally depending upon you that how you are going to carry out your surveys, all right. But it is only applicable if your land is basically uh, continuous, no mountains are there. If the mountains are there, then we use, you can say that, explosive material in order to generate seismic waves which can pass within a subsurface. All right. So these are basically the things that how we are going to uh, use and how we are going to uh, study all these things. So we have huge course there. So we have too much things in order to discuss, but this course is not for one day and not for 1 hour. So, but I have tried to wrap my lecture and to thoroughly give you the idea that what is basically different exploration methods. So, if you are talking about the oil and gas industry, then there are basically some activities in exploration and productions, or you can say that the oil and gas companies. So, the first one is basically the upstream activity. The third one is basically the midstream activity, and the last one is downstream activity. So the upstream activity is for belong to such type of companies which are basically responsible in order to carry out exploration and in order to extract the hydrocarbons from the subsurface, or you can say that from specific fields, just like ExxonMobil, just like you can say that the OMV, just like ENI, just like BP. All right, so these guys are basically known as or belong to OPEX team activities. So we have another basically activity, and this type of activity is known as midstream activity. So midstream activities are basically the activity which we can basically collect all these hydrocarbons and uh, you can say that drop all these hydrocarbons in refinery, right? So because hydrocarbons are basically the raw type materials, all right? So in refineries they are going to process these hydrocarbons. So these are basically you can say that responsible for midstream activities. Also, these peoples are carried out the collect the hydrocarbons or oil or gas from refineries, all right, and drop these hydrocarbons in specific pumps, all right, different gas pumps, or you can say that the oil pumps. So for example, if you are talking about the UAE, so in UAE the ADNOC group is responsible in order to do upstream activity as well as midstream activity, as well as you can say that the downstream activities. So what is basically the downstream activity? So downstream activity is basically the activity where uh, the hydrocarbon is reached to the customer, all right? So the petrol pumps, oil pumps, gas pumps are basically the downstream activity. So different companies are there, all right? So they are responsible, just like Shell, just like Total, all right? So Shell is doing upstream activities in Norway, all right? So they're also doing the midstream activities in different countries. If you guys have any question, so I can because too much things are there. We have a specific it is basically 7 to 15 days course, so we can I wish in order to deliver all of my knowledge to you guys, right? So if you guys are interested, you have my personal WhatsApp, all right? You can simply contact me and I will thoroughly guide you. All right. So the first question is, thank you very much. So first question is, can you explain the switches spot identification with the help of, because okay, actually I have separate course which is basically related with seismic attributes. All right. So within a seismic attribute, uh, I'm going to explain each and everything. I think tomorrow is my workshop related with seismic attribute. So I'm going to show you seismic section. All right. So this one is basically the seismic section. You can see the seismic amplitude, all right, there. All right. Simple things are there. No, you can see the coherency attribute. You can see that the density variation within a subsurface. Due to density variation, you can see the variation within your subsurface structure, all right? So the sweet spots or dim spots, bright spots, all right? These are basically the things in order to study the seismic amplitude, all right? Because seismic amplitude is not in uniform condition, all right? If there is a gas, if there is some hydrocarbons, if there is gas zone, if there is water zone, then you can see the fluctuation in your you can say that the seismic amplitude. So these sweet spots, bright spots, and you can say that the dim spot initially is known as DHIs, all right? So initially, when they are going to initially when we have such type of when this technology has come to exist in oil and gas industry, then DHIs is known was known as you can say that the dry hole indicator, because on the basis of this technology and the seismic amplitude study, many wells are drilled, and many wells were basically the dry one. All right. So this, with the help of this technique, we can easily, you can see that we can easily extract hydrocarbons with the help of our seismic sections. So sweet spots, bright spots, dim spots are basically known as DHIs, which is known as direct hydrocarbon indicator. All right. So next question. How long will the survey will conducted to collect? It is basically take depend upon your area of your block. If your block is small, then you can acquire the data set within a 1 month. If your block is too much, area of block is too much, then you will carry it out you can take collect your data set up to 4 month, 3 month, all right, 2 month. But the services companies try to wind up their all of their work, uh, you can say that in very short in what is interval of time, because they are interested in order to reduce their budget, in order to reduce the labor cost, so they can keep all these things in their mind. So it is about your block area. Yes, any more question?
Here
No
is a
more question is there. I
question
have already
from
shared
here's
my
the
contact number with
question.
you guys. So if you have any problem, if you have any questions, you can directly send me the WhatsApp voice message or text message. I can thoroughly guide you. Don't worry about that. Over to you. Thank you, and have a good day. Thank you.